चलिए। अरे वो अपने यहाँ
धूप से बचने वाला चश्मा है। आ गया सही किया, शादी के लिए फोटो वो समझ गए। कोई चॉकलेट में चल जाएगा। हो गया। हाँ, फिर नेक्स्ट स्टार्ट किया। ले लिया। ब्लूटूथ भी होगा। उनको दे दिए नहीं तो बैंक तो आगे रख दे।
सिंगल का फोटो देखिए वाला
है बाद में बताऊंगा।
Everyone, please settle down.
Last time, this result. So we got a calculation for W0 space. Now, let's take one example, and this is the Harvard list, for example. Okay. Now, we call V0 in the definition of R and R. And V0 was the function which is constant on the interval of the form take is the so unit the interval, the function is constant. So take function and V0 was our function. So take phi is so phi 0 phi belongs to V0 by this function phi of x. Characteristic function of minus 1. So basically this is the function. 0 minus 1, 0 and 1. So value is 1 minus 1 0 and 0 others. So I am taking 5 to be this, and why I am taking 5 this, I will explain later. Because if you remember, in the example I have taken 5x to be on 0 only. On 0 only plus 1. And now I am taking minus 1 0. So why I am taking this? I will explain. So suppose I take this 5, then again the subjects are this 5. Okay, so suppose I take 5 this, or I take 5 this. What happens to this then? So this family will be the same whether you take 5 this or take 5 this. Okay? So there is nothing going to change in this family. So you can take 5 this also or 5 that one. And we call some points. Okay, so what is that? The things that you find in MRI. Yes. 5 factors right. And 5 factors right, and then this one. So half pi half x. It is written as the linear combination of translates of pi. Okay? And the coefficients are alpha k. And these alpha k, these alpha k will determine your opacity. So I will write with that, as for that pi, I will write this, and then I will expand into 1 of x plus k. So I will get alpha k. So write half pi half x, half pi half x. So this half and characteristic function on minus 2 0. And when x by 2 belongs to this interval, so x belongs to minus 2 0 double of that. And characteristic function on minus 2 0 write it like 1 by 2 and characteristic function on minus 2 to minus 1 and the characteristic function on minus 1 0. And characteristic function on minus 2 to minus 1 is y x. And this is y x. That's it. Minus of minus 1 is shift of this side. So one shift, y x plus 1. And this is your phi x. So half y half x was summation. In the expansion phi x plus k. So I got phi x plus 1 and phi x. So corresponding to k equal to 0 and k equal to 1. I have only two values. So that is half phi x plus 1 plus phi x. So k equal to 0 and k equal to 1. So I will get only two coefficients, alpha 0 and alpha, and the rest are 0. Okay. So I will get only two coefficients. And alpha 0, which is your half, and alpha 1, which is your half, and the rest things are 0. And once you get alpha k, so calculate the low pass filter. The low pass filter M0. M0 right is by the definition it is alpha k e power I psi k. So only two values I have. So this is your half plus half e power this I k. Alright. Alpha equal to 0, so k equal to 0 and k equal to 1 and rest of 0. So this is your low pass filter. Okay, now I have to calculate scaling function for this. So for scaling function, scaling function is this. So Fourier transform. So phi cat line. So phi cat line is integral 1 half phi x e power minus psi x dx by the definition of Fourier transform, and phi is defined by minus 1 0. So this integral will be at minus 1 0 and e power minus psi x dx. So you can integrate it and the final value. Okay, so this will be e power minus I e power I psi minus 1. Now change it into the sine function. So it will be in form power sine psi by 2 sine psi by 2 right. So see here, you have to calculate W0 and W in W0. You got phi tab, you got M0. So put the value here, so you will get psi. Okay, so put the value here. And for simplicity, I have taken this. In characterization, mu is a function whose modulus is 1. So I take mu to be identical equal. So if I take this, for simplicity I am taking this. So this term will go to 1, e power I psi by 2, or write at 2 psi, so it will be e power I psi and this. So put this value. So after putting this value, you will get to psi cut to psi. This is e power I psi, mu is 1, and m0 psi plus pi bar. So m0 is 1 by 2, and 1 plus e power minus I psi plus pi, and then pi cat. So pi cat is e power I psi minus 1 upon pi. Okay. M0 xi, so M0 xi plus pi. So write it xi plus pi and then take bar. So e power I and pi, that will be minus 1. And pi cat xi, so integral of this value. Okay, got this and simplify this. So I am skipping the terms. Final value I am going to write. Final value is e power I xi by 2 upon I xi e power I xi by 2 minus 2 plus e power minus I. So after doing calculation, you can do this. So this is the value of psi cat to psi. Okay. Now take psi x to be characteristic function on minus 1 minus half x minus characteristic function on minus half 0 x. So basically this is the function minus 1 minus half. So minus 1 minus half, this value is 1, and minus half 0, this value is minus. This is your plus 1. Suppose I am taking psi x to be this. So if I take psi x to be this, then 1 second, psi cap, right. So this is your psi cap psi, not psi cap to j. So psi cap to j is this. So psi cap psi will be this. Psi cap. Now take psi x to be this, and again calculate psi cap. So this is an exercise. You can verify that psi cap psi comes out to be this like this. So from phi we get psi x, this one, and this is a wavelet which is Haar wavelet. Okay. Now again, previously I defined Haar wavelet to be this, and 0 half I take value 1, and the half 1 I take value minus 1. This I previously defined this. Okay. But here I am taking this. So again, if I take shift of this, I will get this function. So translate of the family of this is same if I take this side or this side. And why I am taking, why I am getting this side? This is because of this side. And this, which I have taken for mathematics, mu to be 1. So if you take mu to be 1, so you will get 1 shift back of the function. Okay. Now to get the same function, what I can do? I can take mu to be power minus I. Suppose I am taking mu e power minus I. Then this modulus is also 1. So if this modulus is 1, then again by the result it is an wavelet. Okay. And the term which I am getting, it will be multiplied by e power minus I. Okay. So the term e power minus I psi and the rest terms which I calculated. Psi cat psi. Whatever psi cat psi I calculated before, it will be multiplied by e power minus I. And you know one result regarding the Fourier transform, that f(x plus k) is also the same. F dot plus k, its Fourier transform as psi is given by e power I k psi and then after. So when you multiply f cap with an exponential term, in time domain, you get the shift of that function. Okay? So, and in your case, what is your k? K is minus 1. So if you are taking k equal to minus 1, then whatever psi you are getting here, by taking this value, you will get psi of, since x is minus 1, so you will get x minus 1. So if your psi x is this, then psi x minus 1. So when you take that mu to be identically equal to 1, so you will get one shift of that function. So to get exactly that value, you can take mu to be this, e power minus x. Okay. So anyway, either you take this side or take this side, nothing going to be changed because the shift will generate the same value. Okay. So this was the example of Hall wavelet, and that was calculated using the result which you characterize using multi-resolution analysis. Okay. And the next thing is this one. And by that formula, so by this formula and this formula, directly I can get psi cat using the coefficient alpha 0 and alpha. So how to get this? So my psi cat was psi cat 2 xi e power I xi and then mu of 2 xi and 0 xi plus pi bar pi cat. So this was my psi cat 2 xi, and for simplicity I am taking mu to be 1, so I can remove this term. So e power I xi m0 xi plus bar pi cat xi, or m0 xi, which is low pass filter, which is defined earlier, it is alpha k or I k. So put the value of m0 here, and again I am not going to detail of the steps. I am going to write the final step. So finally you will get psi cat xi. This is your summation minus 1 to the power k alpha k bar e power minus I k minus 1 xi by 2 pi cat xi. Okay. So m0 xi plus pi you put, then you will get bar and exponential becomes minus sign and all those calculations, and then replace psi by 2, so you will get psi cat xi. So this is your psi cat xi. So apply the Fourier inversion formula. Fourier inversion. And Fourier inversion means you can get psi x with the help of psi cat. So psi x is your 1 by 2 pi integral psi cat xi e power I xi x dx. So what do I do? What do you do? Put the value of psi cat here and then do some little bit calculation, so some transformation and actually putting. So variable you have to change. So again I am not going to do the lot of mathematics. Finally, what you will get psi x? Psi x is your 2 times summation minus 1 to the power k alpha k bar phi of 2x minus k. So once you know phi and alpha k, from there also you can get psi x. So like in previous case, my phi x was characteristic function on minus 1 0. My phi was characteristic function on minus 1 0, and the coefficient alpha 0 and alpha 1. Only two terms were there, alpha 0 and alpha 1, that is 1 by 2. So in that case, psi x will be corresponding to k equal to 0 and corresponding to k equal to 1. So for k equal to 0, this is your phi of 2x plus 1 minus 2 pi 1. So 2 is here, 1 by 2 is here, so it will get cancelled. Alpha 0, so k equal to 0, so k equal to 0 means 2x plus 1, and k equal to 1 means 2x. So phi 2x plus 1 plus phi 2x. And phi 2x plus 1 plus phi x is directly what you get here. So that is characteristic function of minus 1 minus half, and minus characteristic function on minus 1 minus half. So this is a simple calculation where we get only two terms, that's why it gets simplified. So this was the example. From RMRA, we get R value, and the scaling function was in that case this phi. Low pass filter is calculated this. So all things is calculated here. So one example, and then one more thing. So I talked about high pass filter. So the coefficient which I get here, e power I xi m0 xi plus phi bar. Some books write it like m1 xi is e power I xi m0 xi plus phi bar, and they call it high pass filter. And this filter are connected by this value. This. So m0 xi and m0 xi plus phi. So both value square cannot exceed 1. So one in phi tab I get m0, and in psi tab I get m0 xi plus phi. So one is called low pass filter and another is called high pass filter. And m0 and m1 are conjugate filter. M0 and m1 are called conjugate filter. And based on this, people have a theory that is called conjugate quadratic filters. Conjugate quadratic filters. So lots of studies are going on in this filter theory. So how we can choose low pass filter and high pass filter and those things. So this is another branch of study, filter theory concepts. So people are doing work in this area also. So this was all about this thing, and okay, now come to this point. So as I mentioned earlier that from MRA you will get a wavelet, but not all wavelets are associated with MRA. So you need one example. So one example is given by this, and this is also known as non-MRA wavelet. And this is given by mathematician Jordan. So by the name of this, it is also called Jordan. So Jordan may give this example, and he used the result which I took in MSF. So if psi is an MSF wavelet, so mod of psi cap to be psi cap. So if you want to remove the exponential part, you can write on the side. So just I'm removing the exponential, complex form. So just write section. It was characteristic function on k, and k was a set which measure 2 pi. Okay. So he constructed a k which measure 2 pi such that psi cap is defined on characteristic function on that set. And from there, he proved that it is not associated with MRA. So for that, you need one result. So I am going to show you that result. So what I have proved earlier, that phi cap 2 xi is m0 xi phi cap, and psi cap 2 xi is e power I xi m0 xi plus I bar phi. So mu I have taken identically to be 1. Okay, so calculate this term. Mod of phi cap 2 xi and mod of psi cap. So what it will be? Mod of n0 is I square, mod of n0 is I plus I square, that is 1. Exponential is 1, so simply you will get I plus I. Mod of. Using that low pass filter result. So continue this calculation for this term. 5 cap and 5 cap and 2 square xi and this is your square. So 5 cap 2 square xi plus mod of psi cap 2 square xi this mod square. So this way same way it will be 5 cap 2 xi square 2 xi is replaced by 2 xi and 5 cap 2 xi. So put the value from here. So it is mod of 5 cap xi square minus mod of psi cap and this is 2 xi. Okay. Now continue this process. So what 5 cap xi will be? So 5 cap xi will be in this case it will be 5 cap 2 square xi mod square psi cap 2 square xi mod square plus this term mod of psi cap 2 xi this mod square and this is the mod psi cap. Now again one more power take 2 power cube. So if you take 2 power cube, so here only you will get 5 cap 2 power cube, and in psi part you will get psi cap 2 square, psi cap 2 cube, 2 square, and then 2. Okay. So in general, mod of 5 cap xi this square for another term it will be this is mod of 5 cap 2 power n xi and the rest term summation form mod of psi cap 2 power j xi square varying from 1. So for 2 equal to j 2 to the power 1 to the power 2. If you take 3, so then it will be 2 to the power 3. So in general for n, psi cap will be summation j equal to 1 to n, then 1 term phi cap to the power n. So this will be mod of phi cap psi square. Now I take n to be large. Take n to be infinity. So when you take n to be large, what happens? This term will go to 0. First, phi cap to power n that will go to 0. So finally you will get mod of phi cap xi summation. So phi cap xi square is summation mod of phi cap to j xi this mod square j varying from 1 to infinity. So for this, I have to show that as n tending to infinity, this term will go to 0. Okay. And second thing, I will use this result to establish this. So the relation between phi cap and psi cap. So first I will show that this goes to 0. So for that, calculate this value. Integral over r mod of phi cap to the power n xi mod square dz, and this is same as 1 upon 2 to the power n integral over r mod of phi cap xi. So replace the variable 2 power n xi, replace it by xi dash, so 1 upon 2 power n you will get this. And integral limit and then to infinity mod of phi cap to the power n xi this mod square dz 0 over r. This is less or equal to limit n tending to infinity integral over r mod of phi cap to power n xi mod square. And this is a well-known result in measure theory, and this is called 40. So apply that. So from result to result, apply that. System is this. Okay. And this integral is 1 upon 2 power n integral phi cat right. So this is norm of phi cat right, and which is fixed number because phi is an analytic function. So as n tends to infinity, this term will go to 0. Will go to 0 means limit phi cat to power n by modified. This term will go to 0. So this term as n goes to infinity, the first term will go to 0. So, relation between phi cat and psi cat is established. Now, use this relation for journal element. The journal element is this element. So, take A set and journal take this set. A is minus 32 by 7 pi, then minus 4 pi, union minus pi, minus 4 by 7 pi, union 4 by 7 pi, pi, union 4 pi, and 32 by 7. So he takes this kit.